What is different about these pendulums? What's one thing that you see that's different?
One thing is that they're different. Some of them are different colors.
They have different colors. That's going to help us make some of the observations. Anything else that we see that is different? Yeah.
Some are higher than the others.
Some are higher than the others. Now, what physically about the pendulums themselves is making some of them higher and lower? What part of the pendulum is making them higher or lower?
Some of the strings are bigger.
Some of them have longer strings, some of them have shorter strings. Okay? So, this one has a string that's a little bit shorter. This one has a string that's a little bit longer. So let's see if we can figure out what effect string length has on the period. Okay? So, David's going to help me out one more time. We are going to displace both of these pendulums the same distance, and we're going to release them at the same time. I want you guys to watch very carefully and tell me if you can figure out which one is swinging faster with the shortest period. When you think you've got it figured out, I want you to point to it and tell the color, either blue or pink. Okay? You guys ready?
Mm-hmm.
Ready to observe?
Mm-hmm.
All right, here we go. 3, 2, 1, go. All right, which one?
Blue.
Which one? Blue. The blue one is swinging faster. It's got a shorter wire, a shorter string. It has a shorter period. Now, of all 15 pendulums that we have, which one is going to swing the fastest? Point to it. Which one's going to swing the fastest? The one with the shortest wire.
Mm-hmm.
Shortest wire, shortest period. Which one is going to swing the slowest? Point to it. This one. Longest wire, longest period. Now in just a couple seconds, we're going to release all 15 pendulums at the same exact time. Now when we do that, they're going to start out swinging together. We have a sciencey term that we use to describe when things are together and in sync. We call that in phase. But since they all have slightly different lengths and therefore slightly different periods, they're very quickly going to get out of sync and get out of phase with each other. And they won't be swinging together. And at first, there'll seem to be no pattern at all, but miraculously, magically, new patterns will appear. Now, do you think it's actually magic?
No.
What did you learn about magic? What is it really?
Science.
It's really physics. It's really science. And we can figure out how these patterns work. So I want you guys to help me look for these patterns that emerge and then disappear, and new patterns that emerge. But the best place to observe this isn't from the side. It's easier to see these patterns from one end or the other. So we're going to pause the demonstration right now and give you guys a chance to walk around either to this side or around to this side so that you can get a better view of this. And I'll meet you guys.
Auntie Julie. Look around.
I don't know. I saw it.
Somebody. Really? Yeah, I'm using my YouTube channel.
So, one more time, let's review. Which one is going to swing the fastest?
For me.
All the way over here. The shortest wire, shortest period. Which one is going to swing the slowest? The one all the way over there. Longest wire, longest period.
Stop pushing.
And all the others going to swing at different periods in between. Okay, remember, I want you guys to watch very carefully for the patterns to show up, disappear, show up again. But in order to get this kicked off, we need a really strong foundation. You guys ready? Don't just nod, let me hear you. Are you guys ready? Yeah! Are you guys ready? Yeah! One more time, y'all ready? Great, okay, here we go. 3, 2, 1, go! Okay, so they're all swinging together, but look, it's already getting out of phase.
Doesn't it look like a snail?
It looks kind of like a snake, right? Where the shortest pendulum, they are
I don't know if you guys can see it good, but
the head of the snake is leading the way.
like a snail.
As we continue to watch, that snake is going to get more and more twisted until it gets kind of jumbled up. We really can see a pattern anymore. Right now, it looks very chaotic, that all the pendulums are just kind of doing their own thing. But if we continue to watch, let me know if you see a pattern. I'll give you a hint. Watch the pendulums that have the same color. The green ones, the blue ones, the pink ones. What do you notice? What do you see? All the light color ones were swinging together. There were 4 lines.
Now they're
Now that pattern has disappeared.
What's up, YouTube? How you guys doing today, YouTube? What's up, YouTube? Let's go, YouTube.
How many lines do you see? 3. So we have a pattern with 4 lines and a pattern with 3. Can you guys guess what's coming next? 2. That's a very good prediction. Watch. Let me know when you can see the 2 lines show up. Does anybody see the 2 lines yet?
Yes.
Kind of like 2 snakes slithering back and forth, right? Almost a DNA double helix kind of shape. At this point, we're at the halfway mark of the pendulum wave cycle. And we're going to see that same pattern of 4, 3, 2 play itself in reverse. So that pattern 2 is disappearing now as we speak. Next, we should see the pattern 3 reemerge. Everybody look and let me know when you can see the 3 lines. You see it?
Yeah.
Right there, 3 lines swinging together.
And then 4.
This pattern is going to disappear. What's next?
4.
4. Watch to see the light-colored pendulum swinging together. There they are. And now that pattern is going to disappear, and the single snake is going to start to re-emerge. Only now, remember when we first had the single snake? How the shortest pendulum was the one leading the way? Which one is leading the way now?
The tall.
The longest one now. And this snake is going to slowly straighten itself out as all of the pendulums get closer and closer to being back in phase with each other. And that's when we know that we've seen the entire pendulum wave cycle. We're getting closer to that now, and they're completely back in phase now. And if we continue to let this play out, we're going to see that pattern go over and over and over again. I think this is an excellent example of one of the most important things about science that scientists look for, and that's patterns. When we look at nature, a lot of times things seem chaotic, things seem like they don't make any sense, things seem like they're not related to each other, but if you look carefully, and make careful observations, you can find that there are actually many, many patterns in the natural world that can help give us clues as to how the natural world works and why the universe is the way that it is. So that's one of the most important things that scientists look for. It's one of the things I want you guys to look for as you go through the rest of today's City of Science. Please make sure you stop at all the stations, check everything out. Hope you guys have a great day. This has been the Pendulum Wave demonstration. If you have any questions, find the site.
We're coming back to the live stream, and today we're going to go back. No! Let's go, guys. Let's go, YouTube. Yeah, it's your boy, Justin Taylor here. You know what I'm
It's your boy, Ninja Blade Taylor. It's my bro, Obadiah and Elijah. And my bro, Shamar.
Hey guys.
Yes. Can we do
And it's your boy.
Hey, come. Hey. There's Auntie Julie.
Who's over there?
There is Auntie Julie.
Over there.
Out here?
Yes, I'm sorry. Yeah. I'm sorry, I got some bats in the cave.
I think I got it. He says sucker one.
Oh no, bats in the cave.
What's the word?
Justin. Guys, we're getting to the bottle drop. Hey. It's here. It's here. Yes.
It's your boy named Blake. And it's your boy Shamar. As you can see. Sit down again.
You guys were just standing there watching.
As you can see, look at Shamar.
Me and Elijah were sitting.
No.
Let's show them some.
Let's show them some.
Did you see a water fountain?